Your regression suite takes 4 hours to run. A developer changes one line of code. You run all 2,000 tests anyway. Not because you think 2,000 tests are needed, because you have no idea which 12 actually matter. Your CI history knows. Every run, every failure, every file that changed, you have been recording the answer for years. You just have not been reading it. Welcome to the AI Tester Dictionary, where we break down one AI term at a time from a software tester's perspective, mostly about using AI to test better. Today's term is machine learning. So, what is machine learning really? And what can it actually do for you this week on the suite you already have? Machine learning is software that learns patterns from data instead of following rules you wrote by hand. You do not tell it what a flaky test looks like. You show it a few thousand test runs, and it works out the pattern. The output is a model. The model makes predictions. Machine learning sits inside artificial intelligence. Deep learning sits inside machine learning. So every machine learning system is AI, but not every AI system learns. And this matters. Automation is not machine learning. A scripted test that runs on every commit is following your rules. Nothing is learning anything. So, why not just write the rules? Try writing the rule for which tests to run. It depends on the files touched, the history of those files, who changed them, what broke last time, and how the suites interact. Nobody can hold that in a set of if statements, but it is sitting in your data. Here is the shape of it. You start with labeled examples, past CI runs, and whether each test passed or failed. Training finds the pattern that connects the change to the outcome. That produces a model. Then inference, a new commit arrives, and the model ranks which tests are most likely to catch something. Training is slow and happens occasionally. Inference is fast and happens every commit. Say you point this at your own pipeline. The model reads the commit. 3 files changed, all in payments. It ranks your suite and puts 60 tests at the top. You run those first. Failures now surface in 4 minutes instead of 4 hours. The rest of the suite still runs overnight. So what do you check? Whether the tests it ranked low are ones you would have been comfortable skipping. This changes what you are responsible for. A scripted tool behaves the same next year as it does today. A model does not. It was trained on the codebase you had, the tests you had, the failures you had. Change any of those, and the predictions quietly get worse. Nobody gets an error. The ranking is just less useful than it was. Which brings us to how this goes wrong. Biased history. If your suite never covered a risk, the model will never rank it highly. Drift. The codebase moves, and the model does not. Overfitting. It learns last quarter's failures rather than the shape of failure. And false confidence. It ranks a test low, you skip it, and that is the one that would have caught the bug. So, machine learning. Software that learns patterns from data instead of following rules you wrote. It is one ring inside AI, and it is the ring most likely to show up in your pipeline first. Treat a model the way you treat any dependency. Ask what it was trained on. Ask when it was last retrained. Ask what happens when it is wrong. That is machine learning. Next episode, we go one ring deeper into deep learning.